content to make a quiz. So, yeah, maybe depending on how far we get today, it might be the same thing. But today, the idea is to introduce you the controller, and we're going to bind the drone to your controller. Binding is the term we use to connect your controller to your drone. Okay. So if you recall from the past, let me scroll back up. We have different frequencies. This is the video frequencies, by the way. So we are talking controller frequency. Do you remember what type of frequency we're using for this?
2.4.
Yeah, 2.4 gigahertz, right. So, okay, right here, I'm going to bring this up again because we're going to be talking about this again. On our controller, we have a firmware, EdgeTX, and how we talk, the protocol, think of it as the language, we're going to be using Express LRS. I think those building their own drones is the same thing as if you bought the recommendation I gave you, but there are other protocols / languages. Did you have a question?
Yeah. As far as the binding exercises is concerned, those of us which are building our drones, from the kit, will we be doing it?
Yeah, you can still bind to this. Does everyone, starting off, does everyone have a controller that you're charging? Because we need to use these. Yes.
The kits that people are building doesn't come
They don't
with
have
an
controllers, so you're using the classroom ones
ELRS.
temporarily.
It doesn't come with an ELRS.
I know, it doesn't come with anything. You had to buy that receiver separately. Matthew has extras if you want to talk to him.
Yes. Spectrum is 2.4 gigahertz, right?
Yes, I think so.
Okay, because they do call their thing because I know they try to proprietize and they do call their protocol something separate. It's called like DSMX.
Oh, I think that's just their name. Yeah,
okay.
but the frequency is still 2.4. DSMX. Yeah, actually, speaking of which, that's a good point. I'm gonna bring out some receivers here. So if you have your drone that we built, actually, Matthew, can I see one of your receivers if you don't mind?
Oh, receiver?
Yeah. Oh, actually, I'm just gonna. Or if I could look at your tools. Okay, perfect. I'll leave it in the bag.
You're good.
Okay. Okay, so this is how everyone's mostly going to be set up. Oh yeah, remember, everyone needs to have a controller and charging it. Make sure it's red.
Do you have any more of those controllers?
Check over in the cabinet. If not, you're going to have to break out one of the bigger controllers, which will still work, but it will be different, slightly different. Grab the TX16. That's going to be a bigger one. Anyone else? Okay, so we have 3 different USB ports on here. Kind of confusing. Make sure you're using the one on the bottom that's plugged into the controller. That's going to charge it, because it's going to turn red. There's another USB port on the external module. Okay, don't plug into that one because that one's not going to charge it. And then there's another one on the top. All right, so I'm going to keep this plugged in. Okay, on the topics of receivers, I'm going to show you a couple different flavor of receivers.
You said you plug it in where?
Plug into the bottom, black.
The bottom, the USB-C on the bottom.
Yeah. Okay, here I have one of the different receivers. This one's a Spectrum receiver. And if you look, it actually has the different labels on here. So this is like kind of designed for a plane. But we have aileron, elevation, rudder, gear, auxiliary 1, 2. So this, and throttle. So this has 7 channels. You see right here, it even says on there, 7-channel receiver. And if you look, it has individual pins for each channel. So this is like a traditional PWM receiver. you have a dedicated pin per channel. This is kind of outdated now. We don't really use this. But the nice thing about this is if you're building a plane, you do not need to have a flight control board. You literally just plug in each of the associated movements with that thing. So this is the same type of plug that you'll see on a servo. Do you guys know what a servo is? It's like a little motor. Let me show you. So servo motor looks like this. So I go over this in the other class. Just like this. You see the plug? It's a 3-pin plug. Power, ground, and signal. And this is typically used for the wings, the flaps. So then you can plug in specific rudder, and it'll change the tail flap. Okay, so that's why they use this for the planes, because you plug it in directly with power, and you don't need a flight control board. But yeah, that's PWM, pulse width modulation. That's what it means. What it's doing is each one is sending its own dedicated signal on its own line. So channel 1 is only going to send out signal when it's activated. Let me show you another type of receiver. This one is, I don't know which company made this one. I don't know what company made this one, but you can see that there's only 3 ports on it this time. 1, 2, 3. I did kind of a bad job soldering it. But it had 1, 2, 3. So plus, minus, and a signal in the middle. And then right here, I have the same type of plug. And here, it's not just one channel. It can have multiple channels. But they have PPM. And that sends it in sequence, one after another. So channel 1, then channel 2, then channel 3, channel 4, channel 5. And then it cycles back again. It'll keep repeating it in sequence. So that's how they're able to fit all that into one connection, because it's more of a time-based thing, right? Versus like having a this is like having a dedicated checkout lane. All right, this is like having one checkout lane, but they're calling your numbers, now serving number 3, okay, and then now serving number 4, and then they'll recycle the numbers. Okay, we're done. It's like in and out, right? They after 99 they go back to whatever 1, customer 1. So yeah, that's this type of system, the PPM. So this is pulse width modulation, PWM, PPM. Now we're using serial port. They look like the PPM. Okay, this one in particular is, you can see right here, it's an ELRS receiver. If we look closely, you see there's 4 pins. Now, this one has an extra pin. So we have, what's the 3 main pins we had on the other one? Power, ground, signal. So this one has a 4th pin, and that's to send data back in what we call telemetry. Okay, so you see how on your controller we have screens. So this screen can tell you things about the controller itself, but it can also tell you things that's happening on board the drone. Well, how do you do that? You have to get data back out. So that's why we have a 4th pin to periodically send data back out. Now, it works kind of like the other one, the same way, the PM, where it'll send a bunch of signals in sequence, but then like the 20th packet is coming back. So 1 through 19 is like sending stuff there, and then the 20th is coming back. The reason they only do that periodically is because, 1, you don't need like millisecond updates, right, on the battery level and other details about your drone. It's like maybe once a second is okay, right, to see that type of info. Versus flying it is more important that you have like immediate live feed to it. So that's kind of what they do, is just prioritize sending data over and then once in a while getting data back. Do you need telemetry to fly? No, you don't. I mean, right? These other ones don't have telemetry. It's just that you're kind of sending signals to the drone and you don't know what's exactly happening on board. I mean, if something's going off and such. So yeah, this is what we called a serial serial digital connection. Okay, so when we set this up later in our drone on Betaflight, you're going to select serial port. And I'll show you all that. So digital is because it's sending ones and zeros. Okay, that's what digital means versus analog. All right. So that's our receiver. Any questions on that? Just wanted to show different examples here. It's hard to tell. Like I couldn't tell just by looking at the other one, like what type it is. So you might have to look up a serial number and such, and then find it on the documentation, the manufacturer documentation, to figure out what exactly it is, all the details.
Real quick, digital things ones and zeros or analog?
Digital. Digital is 1 to 0. Yeah.
I had it back.
So we have the digital system here. Okay. All right. Okay. Here is an overview of how these are connected. So we have our controller right here, also called the radio. So you're going to hear these two terms interchangeably. That is wirelessly sending the signal over to your receiver right here. Can you find the receiver on your drone? So on these drones, it's that little thing that's tucked away. It has it should have 4 cables coming out of it, right? Okay, mine is right here. Mine is right here, you see? That's the receiver. I know it's tiny for what it does. But remember, it's just receiving signal, so it doesn't have to be as big as like the VTX, which is actually transmitting signal. This little thing right here, this little box, is the antenna. That's the antenna right there. So they come in different shapes and forms, not always just like, that the wire that you might be familiar with.
So this whole bottom backboard is a VTX then?
That's a VTX,
That whole-
exactly, yeah. So you can see we have our 4 wires coming out, so it's the same thing probably. RP2, that what it says? Okay, RP2. So I can look up this documentation.
I got a question on
Can
that.
I see that picture one more time?
Yes.
Is that like a vertically polarized antenna, or is it?
Let's find out. So, antenna. Okay, so RP2 and RP1, that should probably mean right polarization. Let's see. Specifications, antenna. Well, RP2 is what we have, right? Oh, it even tells you how to configure it in Betaflight. You see right here? You want to turn on serial RX. Now, UART2 is going to depend on how you actually wire this to your drone. Does anyone have their top lid off that you can still see how this is? You didn't solder it if you used the class kit. So they should still, yeah, but that's not the class kit. So you soldered it. So you have to see, if you didn't use the class kit, you have to see how you connect it to UART. But the class kit, I believe they're all connected, pre-connected. So they should all be the same UART. See, this example, they just said UART2 as shown above. That's just an example. You have to see what you actually used. But anyways, back to your question about the antenna. I don't know. Like, I don't know what type of antenna that is. What did you want to know, Jason?
How it's polarized.
How it's polarized.
It's circular, or it could be, I don't know if it's vertical, I don't know if it matters on that one.
Antenna.
You said right hand, so I'm guessing.
I think that's what the RP means. Yeah, it doesn't say much. Yeah, I'm not seeing any details about it. Yeah, there's a right hand, left hand polarization. It's like kind of like how it sends the data out, like in a clockwise, counterclockwise fashion. You kind of just want to match that up with your drone. I think right hand is kind of the more commonplace polarization. So yeah, that's the receiver. We have to make sure this is ELRS because that is the protocol we're deciding to use. So remember, you need to match the receiver protocol with the controller protocol. In our case, the controller that we're using natively does not come with ELRS, so that's why we had that external module that we added on the back. Remember right here, external module. That allows you to expand capabilities. So that's that white thing in the back.
Okay.
Without that, you won't be able to talk to this ELRS.
So I think just based on the way it looks like it's gonna be a vertically polarized antenna.
Okay. Yeah, vertically polarized. Yeah.
But I thought it sort of is.
And how does,
See, this is what I was talking about. Right hand and left hand polarization, like kind of how it's coming out of the antenna.
do you need corresponding?
Yeah, you need to match it up with the one that the drone's coming out.
So you want it oriented in a horizontal plane, like the board.
Yeah. Yeah, you should, I guess. You should orient it in a specific way. Because there's like omnidirectional antennas, which kind of just like gives out a signal, but I don't think it goes as far. I'll go over that a little later. Right now, I don't want to go a little too far off topic. I have some slides on that later, like the polarizations. Okay, so back to this. We have radio and then we have receiver. Then the receiver is hardwired into your flight control board. And then we have our ESC. So these are actually our three different, we have our three different protocols. All right. So here is the wireless protocol, okay, ELRS. Other ones are also usable, but I'll just stick to the ELRS for now. The ones I showed you previously, this is the Spectrum one I showed you previously. That's kind of proprietary to their own company. ELRS is open source, so that's what's nice about it. So you'll hear a lot of different names. If you see these, just know they're different transmitter wireless protocols. Then we have the receiver protocol. That's the wired connection. So we're using CRSF. And this is kind of grouped with multiple different protocols that you see previously. So you see we have ELRS here, but then we have TBS Crossfire and Tracer. These are things that you saw separately listed here. So in Betaflight, you have to go and choose CRSF if you're using any of these. So this is, again, the hard wired connection. And that's why we choose that in Betaflight, because this is how the board, the flight control board, talks to your receiver. So you can change the way it talks to the receiver. So if I use Spectrum, then I have to use Spectrum. Or use one of these other wired protocols. So wireless, ELRS, TBS, Crossfire, TBS Tracer, those are separate. But then when it comes to the wire, they kind of all talk commonly on the wired side. And then ESC itself also has a protocol. There's less of them. So here's the options. I think that we're probably using D-Shot in our drones. I'll see once we plug it in. Huh? It's D-Shot? Okay, yeah. All right, so remember, 3 different protocols. Transmitter protocol, which is the wireless one. Receiver, which is the wired connection. And then ESC, which is also wired, going to the ESC. Okay, I mentioned this previously, but now we can formally introduce it. UART stands for Universal Asynchronous Receiver Transmitter. These are different. This is basically your board's ability to communicate with things outside of its board. So things you can connect to it that requires a UART port, a receiver, a transmitter, LED, GPS, basically any type of input or output device that you want to control or receive data from into the flight control board. What are some other examples? Something you might want to plug into. What's another type of input or output that would take a UART?
A payload. Speaker.
Yeah, you could do that. Speaker. Payload would, yeah, exactly. That would probably, fundamentally, that goes to a motor, right? Like you're controlling a servo or something. Yeah. That would be a usage of a UART port. Now, this can do both receive and transmit, but you can't reassign, you can't split a UART to do two separate things. Meaning like, oh, a receiver, I'm only using the receiving portion. I want to use the transmitting for something that's not a receiver. It's kind of like once you assign this receiver to that one UART, it's dedicated for that one UART. Now your receivers, some of them, like the one I showed you previously, can also transmit, right? It can transmit telemetry data. So that's when it would actually use both transmit and receive. So it's, I guess that's fully occupied. But sometimes, like more simple receivers, it's only going to receive data. So the transmit portion is not really being used. You can't reassign that, is what I'm trying to point out. Like once it's dedicated to that device, it's dedicated to that device. So LED, for instance, LED is really just an output device. So you're going to use the transmission portion for LEDs, but the receiver portion is kind of dead. It's unused, but you can't like reassign it to something else. It's per device. Yeah, that's the key thing. It's one UART per device. You see right here. Yeah, so two-wire protocol for exchanging data. In the end, it's still 4 wires. You have power, ground, and then transmit, receive. So that's why you saw on the receiver here, we had 4 wires. If you have 3 wires, it's because you're probably only using one of the two, either transmit or receive. Digital ones and zeros. So if you're, one of the key features, if you're looking to buy a flight control board, it might have more UART ports, right? You have more expanded capabilities. When I plugged this in, I believe it had 5, and we're only using 2 of them. At a minimum, we need to use one UART port for what?
GPS.
No, you don't need a GPS technically. This one doesn't have a GPS. At a minimum, you need to use one UART port for what device?
RX.
Yeah, the receiver. Yeah, the receiver. Yeah, you need to control the drone somehow. That's going to occupy at least one UART port. Everything else, like GPS, is fancy features. The other home-built drones, or I guess the kit drones that you're going to keep, those ones have 6 UART ports, last I checked. And you are using at least 2 because you're using receiver, and then your drones have the GPS on it. So that's why it needs another UART port. Okay, oh, I said down here. Need a minimum of 1 UART for the receiver. All right.
Where would you find your UART ports?
It is labeled on the board itself.
Should be on the flight control.
And if it's, you can also go online and look it up. So actually, in this image right here, I show a cropped portion of a flight control board. And you can see they don't write UART. UART is right here in Betaflight. They say UART. On the board, they're going to say R3 or T3, which corresponds with receiver 3 or transmitting 3. Those 2 make up the UART port number 3. So if you plugged in this receiver, for instance, to UART port, or you plugged it into R3, T3, you have to turn on the receiver button for UART 3. That's what you would have to do. If you plugged it into 6 instead, you would need to turn on 6. So you can see this one, they correspond accordingly. So look at your manufacturer's documentation. They will lay it out. They'll tell you like where the UARTs are, because sometimes it's really hard to read these. It's like super tiny, the text. So this drone in particular, this flight control board has 6 UART ports. You're also going to notice it has an additional USB. It's not like really a UART port, but this is how you talk to it when you're plugged into Betaflight. So specific inputs and outputs and peripherals also have its own little thing here. So we'll play with it later, but like those that are building your drone to keep, you need to turn on the peripheral for GPS over here instead of just a normal serial RX. You need to turn it on over here. So depends on your device. Okay, latency, if you play video games and such, it's like it kind of sometimes it's a big deal. You don't want to have a delay between when, like you click and something actually happens. So that's latency. So anytime, every connection is a source of delay. So we have a delay from between you touching the stick to when it actually sends out the signal, right? There's a delay within the radio. Then there's a delay from the actual wireless transmission, and then there's a delay from it receiving the signal to it telling the flight control board, and then so on and so forth. You can go from the flight control board to actually telling the ESC, and then the ESC actually turning the motors. In the grand scheme, it's very fast, right? Like we don't really notice the delay, but it's there in milliseconds. But just want to point out that these are some considerations. Okay, I kind of already talked about this. Let me see. Do I actually have a setup? Oh, yeah, okay, good. We're going to bind it now. Okay, so, yeah, this is just a recap again. Remember, we have 3 different protocols. We have the transmitter protocol. That is the wireless one, ELRS in our instance. Then we have the receiver protocol. That's the wired connection between your receiver and the flight control board. That's going to be CRSF for us. And then we have the ESC protocol between the flight control board and the ESC, D-SHOT for us as well. All right. Now I am going to go over how to use this controller, because this is a beast on its own. I'm gonna have to stop charging this one. Huh? Okay. Has anyone used one of these before? I mean, I know some of the FPV people. Yeah, you guys all use these. But you guys used it on like maybe a non-DJI drone? You already used it? Some of you guys, you have the Tiny Hawk, right? Do you have a controller for it and such?
Not like that.
Okay. All right. So this particular model is called the Radio Master Zorro. You can see right here. That's just, I don't know. There's another model out there. Who has the TX16? Oh, you have the 16. Oh, you have the Boxer. Okay. Yeah, that one. Other options out there. I think the main differences just come down to like how many buttons it has. Yeah, that one's gonna have more buttons, and then you have the T16, right? That one has the most. That one's like also big. So get what you need. Remember, it kind of depends on both your receiver's capability to have that many channels and your controller's capability, right? Whatever is the bottleneck is gonna determine how many you can actually use. Generally speaking, you're not using all of them anyways. So what are the channels that you need to use for your drone? Anyone? Let's list them out. Each movement or action is its own channel.
Yes, so
Huh?
acceleration and deceleration.
What is that in drone terms?
Throttle.
Throttle,
Yeah.
yeah. Or elevation, yeah.
Yeah.
There's this one. That's one channel. Okay, what's another one?
Oh, pitch, yaw.
Pitch, yaw, that's 3 now. Roll, okay, there's 4. Any other ones? What else do we need? So that's how you control the drone.
Arming.
Arming is going to be 1. Let's just say I made it to E. That's the 5th channel. What would be a 6th channel you would use?
Manual.
Arming and disarming is part of the same thing.
Flight modes.
Flight modes, yeah. So let's say I'm going to make B. The reason I'm making E, arming and disarm, because it's a 2-position switch. There's only 2 options for arming, right? You're either arm or you disarm. Flight mode, on the other hand, yeah, that will be our 6th channel. We can have multiple options. So, talking DJI terms, we have normal, and then sport, and then cinematic, right? So let's just say that for simplicity. So that's 3 different flight modes, and therefore I'm going to use my 3-position toggle switch. What's another channel usage?
Turn video on and off.
Yeah, so we can do A right here. That's a momentary switch. So as soon as you let go, it pops up again, right? So that could be one if you want to turn on and off a video.
Take a picture.
Yeah, we can do D. All right, so we can do video, we can do photo. Every one of these requires a UART port, by the way. Well, technically not. There's something called mixing. Let's just say for simplicity's sake, every one of these is a UART port.
Video and picture would be different UART ports.
It depends on how it's tied into your device. If your device can recognize, technically it doesn't have to. You can use one UART port and 2 different buttons on it. You would just send out signals differently. This is kind of what I was talking about mixing, where you can have multiple buttons assigned to a UART port, but it will send out a different signal depending on where you are. Like for example, if I held down this button while I flip this switch, it will do something else versus just flipping the switch. It's like pressing like shift on your keyboard kind of deal. Question?
No, I was just going to ask not so much on the FPV drones, but if for Zoom or gimbal. would that be-
Yeah, you could do gimbal right here. Yeah, right here. The gimbal would make more sense to use a dial, right? Instead of a 3-position
But it's
switch.
still a UART.
Yeah. Unless again, like your device, like that can be coupled with the recording feature. If that can like be assigned to a UART, and then you kind of interpret the signal differently. Yeah, depends on the device that you're plugging in. But since those are all kind of related, if your device is a combination gimbal camera system that you can plug in one UART port to control all those, then sure. Otherwise, if it's like a camera and then a separate gimbal system, those would have to be 2 separate UARTs. Return to home would be another one. Yeah. That would technically not be a UART port because that's software, right? Remember, UART is tied to hardware.
Would you tie that to a button?
Yes, you would tie that to a button. But yeah, that would not take up a UART port. Do you guys understand the difference? Why return to home does not need a UART port? Yeah, because I mean, you're using existing things on the drone, the GPS and stuff, and all you're doing is, it's like another flight mode, actually. Just think about it as like that. It's another flight mode. It doesn't, so actually, flight control mode also does not use a UART port, and arming does not use a UART port. Because again, these are all just software commands to the drone. They are not hardware connections to the drone.
So when you say throttle, pitch, roll.
Those don't use UARTs, yeah. But they are assigned channels in Betaflight. You have to, I'll show you the page where, actually, I think I have it up here. Okay, yeah, we'll get to it. But you see right here, we have different channels right here that when you move these things, it will show up on here. So you have to assign this to an action. Sometimes the action is controlling a UART port, but other times it's just doing something internally to the drone's flying behavior. So yeah, physical button doesn't necessarily equal UART port. I guess maybe I'll backtrack on that one. All right. Let's go into this actual controller because this has its own menu system. And we only have the buttons that you can see right here. It's not a touch screen. So the buttons that you see here on the top, those are like actual control buttons for your flight characteristics. The buttons down here, those are for menu and setting parameters, not for actual control of your drone. Okay, so if you look right here, we have a system button, return, RTN, page to the right, page to the left. Then we have MDL, which stands for model. Then we have a scroll wheel. That's how you're going to select things. and you can also press down on the scroll wheel to say OK, and then telemetry down here. So those are kind of our main buttons. I'm going to turn it on, press and hold this. Okay, you see we have Edge TX on here, and the first thing it does, yeah, if you have a controller, you're able to follow along, but I know some of you are still charging. Keep it charging, by the way. We need it charged as long as possible. Okay, let me turn it off again because I want to show you what I did. So when I booted this up, it gave me a throttle warning. So read the message. It said throttle not idle. Press any key to skip. These are warnings on startup because they want you to set your certain sticks to a specific position so that you're ready for takeoff. Well, if you look at my throttle, it's mid position, right? You wouldn't want to arm the drone and all of a sudden it like jumps up, right? You would want to like start from the low position and rev up. So this is kind of giving you warnings to tell you like, hey, you're not in a state to take off. You should fix these. And sometimes that's the throttle, okay, which that was the only error, but sometimes there's multiple errors, meaning like arming switch is also on. You need to disable that, right? You don't want to like turn on and immediately the thing launches off, right? So read the messages. Again, it's just a warning. It said you can press any key to dismiss. So I just addressed the issue by putting the throttle down. Okay, in here is our main view. You can see this is the model name that we gave it. You can change the name. This is the battery level of this thing. So mine looks like it's mostly charged. And then you have other parameters here. This is a timer, which you can set to keep track of how long you've been flying. Yeah, that's because if you look at this interface, it's not as nice as a DJI interface, right? Like you don't have all those nice GUI. It's not in color. It's basic. And also it doesn't give you video. So so it's not. You have to set it up according to what you need. We can step through different views. If I go to page down here, I can step through different views. So this view shows me where my stick is. You see? I'm moving the stick up and down, and it's just showing you where I am relative to the center point. All right? And it's also telling me the status of each of these switches. So if you look at switch A, it's currently up. Which one is A? Oh, right here. I press A, now it's down. It's depressed. Now I let go, it's up. You see that switching? Let me do it on B now. B, where's B? B is right here. Okay, so I'm switching that right here. So you gotta look at the actual controller to see what letters there are, because I don't know why. They're like all over the place. This is A, then this is B, and then C is like over here. Okay, so now let's go to the next page just to show you. All right, this is another visualization of the sticks, right? You see I'm moving the sticks. So whatever suits your needs. If you wanna see it one way or another, this is just a numeric way to show you. So just different displays. Okay, I'm gonna go back to this nice clean interface. What we're gonna do is I'm gonna press the MDL right here. When I press MDL, it shows you different models. So this is one nice thing about this type of controller over the DJI ones. You know how like you buy a new DJI drone, you need to have another controller with it, right? You can't reuse the controller.
One has to have its own?
Yeah, each DJI basically has to have its own controller. This, you can have multiple drones. You can use multiple drones with this controller. Not at the same time. But if you use ELRS on all of your devices, you technically just need one radio. And you just create a new model every time. So right now, if I'm flying my Skylight, I use Skylight model. If I built another drone, I create another model for it. In this case, I'll go to model 2 and I can create a model. And there's model 2. And if I have another drone, go to model 3. So The name is kind of important because, as you can see, it's not really descriptive when you start off. It just says Model 2. So I'm going to let me see. How do you get into it? Okay. So what I did is here. Let me go back to MDL for model. I'm going to press page right, and you see I get into page number 2 of 12. There's a lot of pages. Let me step through some of these pages. We have heli setup, flight modes, inputs, mixes, outputs, curves, logical switches, special functions, telemetry display. Okay, there's a lot of stuff, as you can see. It's going to take forever for me to go through all this stuff. So I'm just going to show you the most important things you need to know. First one is page number 2. Page number 2 is your setup. The model name is the default name. And let's change it to something else. So,
real quick, from the setup with Model 2, how did you get to, you click it?
yeah, so I'm going to go back.
Scroll.
So this is the home page. I'm going to press MDL, right thumb, MDL, and then left thumb, right page to the right. And then we're going to go from page 1 to page 2. To change the name, I'm going to press this scroll wheel.
Nice.
And then I'm going to scroll. Let's scroll. It starts with numbers, and then it goes to capital letters. What do we want to call this? I don't know.
The humming button.
That's too many letters. This is such a pain in the butt. You can see it sucks. I'm just going to call it... Huh? Oh, I already start with H. Hawk. Okay, good. Hawk. We'll call it Hawk. All right. So I'm gonna go to.
You never do my ideas.
Okay, there it is. Hawk. Okay, that's nice. Okay. Now I'm gonna press return so that I get out of editing the name. And now when you're back here, you can continue scrolling and it's going to go down the page. This is that timer I showed you previously on the other model. You can turn on a timer if you want. I'm just going to leave it off for now because there's other settings we need to talk about.
What is the timer for?
If you want to keep track of how long you've been flying. Let's say your drone doesn't have telemetry coming back. How do you know how much battery you have left?
Yeah, you gotta keep track of that.
Yeah, unless you're VTX, that's another thing. If you have OSD on your VTX, you can see the battery level. But let's say you didn't have a VTX, you don't have telemetry back, there's not really a way for you to keep track, so you're going to have to kind of just use time.
That's how I have to do mine on my 5N.
Yeah,
So,
that's like your last resort. Time is not an indication of battery life, but it gives you an idea.
push it to 4.5 minutes.
Yeah.
That's like pushing it.
Yeah.
But I usually do like 3.5, maybe 3.45.
Right. So, and that kind of just comes with trial and error. Like, hey, how much time is equal to low battery? You kind of have to like do some experimental flight and land it, measure the battery. Okay, I can fly a little longer, and then okay, and then you figure out eventually how long that is. All right, what the heck? This thing is frozen. Okay, here we go. All right, let's go down. Look, you can even do 2 timers if you want. Maybe one is how long, because there's multiple ways to count how long the drone's been in the air. Is it when the arming switch has been hit? Or is it when the throttle is above a certain level? What do you consider the drone flying? So that's why you can have 2 different timers. You can also have a timer like how long the radio's been on altogether, not even flying, just whatever you want to do. All right, 3 timers. Okay, we're going to skip through all the timers. You can play with that later if you want. Let's see if there's anything down here we need to do. Okay, nope. We're just going to... Oh, yes, there is one thing we need to do. Sorry, what's that? Persist means that I think it's going to continue to count even after you turn off the trigger. So let's say the trigger for the timer is arming switch, and then you disarm, it will still continue to count because you've already activated it. And it doesn't, yeah, so that would be persist. If there's specific reason you need to have that, yeah, it depends. Okay, at the bottom, this one's going to be important. You see, we're still on page number 2. You can see the top right corner, 2 of 12. We have internal radio frequency and external radio frequency. If we're talking ELRS, are we using the built-in or the external white module?
External on that control, on that radio.
Yes, exactly. Actually, in its current state, you will not be able to talk to anything because we literally turn off both the internal and the external. So that can be really frustrating. I remember the first time I was doing this, I'm like, what the heck is going on? It's not binding because we literally turn off both of them. I don't know why they're both off by default. So you need to turn one of them on. Okay, so we're gonna turn our external on. Okay, and it needs to be. You see, these are different protocols, right? You see that? Which one do we need out of the ones I pointed out? So we have off, which is not a protocol, but PBM. Yes, CRSF. This one. Let me see what else we have here. Multi. See, there's a lot. There's a lot. No, D-Shot is for ESC. We need CRSF. You see that? Okay. So those are the two things you need to do on this page. The name and external RF to CRSF. Make sure your internal is off. I don't know what happens if you turn both on, but you can't use both at the same time. Yeah, so. Okay. Next, we're going to go to page right. Let's go to page number 3. We're going to skip this one, heli setup. Okay, we don't have a helicopter. We can skip this one, number 4.
What is that one used for?
Honestly, I have no idea, but I don't usually configure this thing. Okay, this one we will need to configure. So inputs. Inputs is what input on this are you accepting? So we have 4 set up by default because you kind of always need these 4. Remember, they're using the terms when it comes to like planes. So aileron, elevation, throttle, and rudder. So they're not going to line up with what you might be used to with pitch, yaw, roll, whatever. So we're going to keep it as is, right? Because we want whatever aileron is supposed to be, we want that to be the aileron. Doesn't really matter because ultimately in beta flight, we can mix and match later. As long as you have these sticks on, that's what we needed to do.
What does inputs 4/64 mean?
That means you have 64 options. We only turn on 4 of them. So there's a lot. I can scroll down this list. We can turn on a lot. Yeah. It has 10 turn on? Yeah, because these are already previously configured. What I would do is make a new model, and that way you're in the screen setup that I'm showing you. Kind of, it's like it's starting from fresh again. Okay, so we talked about a couple other things you might want to do. Besides the 4 control motions, what is another type of, like...
If you had a servo,
Yeah.
would that be?
Yeah, we would need to turn on one of these things. Well, remember, this is inputs. So what inputs on your physical controller do you want to accept? Like starting. So servo is not an input, so you don't technically need... There's ways to start in servo. You can have a servo move based off one of these things. These are already one of the things that are going to move a servo, assuming you have a plane. Or you can have a servo move off of like time or whatever like that. So this is not a servo is not a physical input on this thing. What were you saying?
Like to start a video.
Yeah, so you would need a button, for instance, right? So you would need to turn on one of these. Number 5. Let's say number 5 is going to be the one to turn off video. But before I do the number 5, because that one's not as essential, what's an essential thing you need to have? We talked about it previously. Arming. Okay, let's make number 5 arming. Okay, then we'll add on the video. So what I'm going to do is, once again, I'm going to press on the scroll wheel Okay, it's going to enter input number 5. That's I05. And on the input, you see how it is highlighted, the 3 dashes? You are going to physically hit the switch that you want to assign. Oh, I'm sorry. Press in the scroll wheel. Okay, now it's that. Now I'm going to physically hit, come on. Oh my goodness. Wait. Okay. I think it's this one. Sorry, I need to play with this a little bit. I think I just renamed this whole thing. Yeah, okay, sorry, my bad. I renamed this thing. Okay, I'm going to put it back to 5, right? Oh, source, that's what we need to do. We need to go down here. Okay, you see source? I'm going to click on that. It's flashing. Now you want to hit your actual thing. So I'm going to use switch number E. E is this one right here. This makes the most sense for me to be the arming switch. You see, if I hit something else, it reassigns it. Now it's switch B. Now it's switch 1. But I want number E. So make sure you put number 5 to E. And we are done here. I'm going to press RTN to return. Okay, you see input number 5 has been assigned to switch E. What's the 6th input we might want to put into our drone?
Flight mode?
Flight mode. Let's enter that. I'm going to scroll down to source. I'm going to click on the scroll wheel. And what switch do we want to use for flight mode?
B.
I agree. Let's use B right here. This is a 3-position switch. I'm going to hit it, and it's going to go to switch B. Just like that.
And then you
How
can
does it know you've got 3-position switch?
Oh, that's just the hardware.
Not so much that.
It doesn't know.
But if I'm in the upper position, how does it know what the upper position is?
Yeah, I'll show you. There's a screen. I think that's the next screen that will show you. Basically, we have, and same with Betaflight, it will show you a reflection of this. It goes between 0 to 2,000. So this will be, one position will be 0, the other will be 1,000, the third one will be 2,000. Versus the 2-position switch is just going to go between 0 and 2,000. That's going to be like your 2 options. A dial is going to go anywhere between 0 to 200. It could land on 375 or whatever like that.
And we, on this screen, we can confirm that it is working, because as we switch it, we change the values.
Right, exactly. Yeah. And then just double check that what you actually have, switch B, is what you see on the screen. That's what you want.
So for each 3 values, you have to enter this 3 times?
Huh? No, you don't.
That switch has got 3 switches.
Those 3 switches are just values within that channel.
Okay.
So,
We'll assign the channel later.
yes.
Okay.
Yeah. So, actually, my OCD, I'm going to go back and change this to 0.5 just to match the other ones. Let me edit this, and I'm going to go to 0.5. 0.5. Okay, good. Now I'm happy. Okay. Let's do for kicks and giggles, let's do the record button, okay? So what button do we want for record? A. Okay, right here, A. So I'm going to press A, and there it goes, switch A. Okay, so at the moment, I only use 7 of these inputs. Let's say later on, you want to do more, you're going to have to come back into the radio menu and assign it. You can't later, let's say later you're trying to use one of these. This does nothing right now because we did not assign these to anything. If you want to use it later, you have to come into the radio and activate it. That's kind of what we're doing right now. We're activating each of these inputs.
And then in Betaflight,
We have to assign that to an actual action that the drone will interpret.
Yeah.
It will interpret this, and you want to assign an action to it. Yeah.
It's like right now we're activating it as an input source.
Right. Right now we are activating it as a input source.
Registry.
Right. So that was page number 5.
Excuse me, when we're actually, mapping this to, the controller or the, drone, are they both connected to the computer for data flight simultaneously?
This is not the controller is not connected to Betaflight. It's just going to be its own thing like I have right now. You turn it on, and then when you hit something, like I hit a switch, it will show up on Betaflight because, well, that's after you binded it to the drone. It's sending a signal to the receiver, and then the drone's going to show that on Betaflight. So we have to bind it before we can do that. Right now, we are unbound. This does not know the drone's existence.
Thank you.
Yeah. But yes, later, this will just be wireless on its own, just like in real life. And you hit a switch, and if you bound, it will show up on here. And you'll see that in Betaflight. Okay, so that's input. Now, the next page is mixes. Okay, mixes is also something you have to do. This is where it's a little confusing. We gave it 7 inputs, right? Those have been activated. But at the moment, we are only sending out 4 channels to your receiver. All right, so let me repeat that again because just to make sure we're all good. So right here, in this page inputs, I said only these 7 things are activated. That doesn't mean it's sending 7 signals. It's just saying, okay, I accept you in. You can be present, all right? This one is actually sending a signal out. Notice the name changes. It says channel now, all right? The reason it's called mixes is because you can mix, kind of like what I was saying earlier. You can have multiple inputs control a single output. Or you can have an input control multiple outputs, right? This is where you can mix and match things. We're just going to keep it simple and do 1 input to 1 channel. All right. Later, you want to play with it, you can play with it and mix and match multiple things.
So your arming switch comes after all of those are receiving data.
The arming switch.
When you were talking about mixes, so that some things don't need to be on at the same time, but all of these are on automatically, but wouldn't you need a signal to your arming switch that's on all the time? Because if it's either on or off, it has to know before it can tell these 4 what to do. If you're not armed, then all those would be 0, right?
So not sure I'm understanding, but let me try to explain this.
That's fine.
So right now, what we did in this previous screen, we made these actual, we made them usable. These on the right side are not usable because I did not set those as inputs. So you can consider them like non-existent. Even though they're physically there, we are not actually going to be using them because I didn't set that as an input. Oh, I'm sorry. Now, mixes is where we actually say, well, what do you want that button to do? Do you want it to control channel 5? Or do you want it to control channel 6? Or if you're mixing, control channel 5 and 6, right? You can do multiple things with this button. What do you want this button to do? That's what this is saying. So this controller, for all it does not know what you intend to do with switch number E. It doesn't know what you're going to use it for arming. That's actually later in Betaflight. We have to tell it arming. Because arming is something specific to a drone, not this thing. This thing doesn't know what an arming is. It doesn't know what a flight control mode is. Yeah. There's multiple levels of settings. That's what's kind of confusing. Like this, you could use this for a rover, a wheeled rover. Like all it knows is I'm sending out signals to specific channels. I don't know what you're doing with those channels, but all I know is I'm sending out specific channels. And these are just names we gave to it. Aileron, elevator. You could have called it 01, 02, but this is the default names. So right now, as it is, we have 7 inputs activated, but in the end, we're only sending 4 channels of signals. Well, we want to use those other inputs, right? We activated them for a purpose. So let's do that. I'm going to go here. Oops, why did I do channel 6? I'm going to go to channel 5. Channel 5, what source do you want? Okay.
Well, that's blurry.
Oh, okay. Channel 5, well, to keep it simple, this is what I was saying. I want a 1-to-1, meaning I want input 5 to control channel 5. I mean, look, I could have said elevation controls channel 5, but to keep it simple and straightforward, I'm going to say input number 5. Do you guys remember what input number 5 was?
Arming,
Yeah, which was switch E.
yes.
Switch E, which is input number 5, is going to control channel number 5. So later, when we go into Betaflight, we're going to see channel number 5, and we have to assign that to arming. Okay. All right, so
Add a mix name to it as well.
I didn't. I just left it, and then if you don't put a name, it just defaults to whatever your input was.
Oh,
So we're going to also do number 7, because we did 7 things, right? And look, by default, it just assumes you want input 7, so I'm not even going to change anything. But if you had to, you have to scroll down here, and you have to change it. We can see right here, now, we have 7 inputs, 7 outputs, and they match up perfectly, just like that. And let me draw this. This might actually help. So, because I know there might be some confusion on how this works. So right here, we have, I'm just gonna draw like this, like as a button, okay? 6, 7, okay. So this is like physical control. Okay, and then in the radio, we need to activate. So we're going to activate this, and we're going to call it input. Well, they call it aileron, rudder, whatever. So there we go. Okay, then we have to do something with it, mix. So this is assign channel. That's what this does. Now what we did is we did a 1-to-1. Six. Okay, 1-to-1, right? This goes here, this goes here. What you could have done is, input 1 can do channel 1 and channel 2. And input 2 could have done channel 2 and channel 3 if you wanted to. That's where you can mix things. But we kept it straightforward. And then later in Betaflight, we're going to see those channels, and then you're going to actually give it an action. Elevation on the drone. Yaw on the drone. Pitch, roll, and then what do we want channel 5, which is tied to input 1 to do? Arm. And then what is channel 6? What do we want that to do?
Flight mode.
Flight mode. And then what do we want channel 7 to do? Record. That's not actually something, I'm not sure we can actually set that up, but this is just for hypothetical. Okay, see right here, this is like the 3 different levels that you need to, that we need to like assign. Does this help? Like kind of giving you like a high level overview. Right now we are, oops.
There's no T, we can't see channel 7.
Yeah, I kind of. So right now we are just dealing with this. This is the radio. Later, this is flight control board. Okay, so back here again, we were on mixes, all right? Outputs, we're going to keep as is. Outputs here, you're asking, Oh, how do you know? Here, let me see if I can move all these. Oh, maybe it's the next page. Curves, switches. Okay, these kind of get more into characteristics of how you want this to send data out. Do you want it to send a 0 to 100, or do you want it to send 0 to 50? Just leave it at the 0 to 100. We'll just keep this. So skip this page. Skip this page. Curves. It's like, how does it send it? Does it send it linearly, or does it send it like in an S curve or something like that? All right. Logical. We'll skip. Sorry, what's that?
Would you use that if you're like trying to tune the planning?
No, tuning.
Slower, go faster?
You can. When you say tuning, I thought you meant like how the drone responds to input. That's generally like a Betaflight thing. But if you want, okay, so the curves is basically saying like when I go here, it's going to linearly go 0 to 100. If you have a curve from here to here, it could be very slow, and then all of a sudden it ramps up between like 20 to 80, and then it slows down. That would be like an S curve. That would be like that's like a characteristic of how you're sending the data. Even though you're linearly going up, it can send it like very dramatic as an output. But if you're tuning it in terms of like how it behaves in flight, that's more like a Betaflight tuning thing. Yeah, because that's with the flight controller.
So I got a question on that. So we had it set to 100, that means linearly, it's actuating at a constant rate?
The 100 is telling you the range that's sending you.
Okay,
It's
so
sending it from 0 to 100.
It's 100%.
How it's sending it is the curves.
Curves,
So you can see we're all linear. We're just 0 to 100. If you're 99 on here, it's 99 on the output. If you're 65, it's 65. Versus like a curve can be like a different number for a different position that you're at.
You said you could vary the rate though, which.
Yeah. But I'm skipping that because it's like, I don't want to like complicate it too much. So linearly, we're just sending a linear signal for now. Matthew, can you turn on the fan?
Yes, sir.
When would you want a nonlinear signal?
I know some people like flaps. Do you fly fixed wing? I don't fly fixed wing. I have no.
You don't wanna just go sometimes just all at once, because it's so much of a correction.
Okay.
You want it kind of gradual.
Yeah, so I guess fixed wing might need flaps. I don't know. I don't really use.
Because now you can adjust the controllers on a DJI controller.
Yeah, exactly.
In a million
I guess it comes down to like, I don't know. I have no idea. Huh? That's Expo. Yeah, that's basically Expo.
Yeah, smooth out center sensitivity.
Yeah, right. Yeah. It's kind of preference, I guess, like how you want to fly.
You're trying to be real smooth.
Okay, so we as a recap, we changed setup, we changed the model name, and then we changed the external to Crossfire. Page number 5, we changed the inputs, we activated it. Number 6, we assigned the inputs to a specific channel. And then I think that's it. Yeah, that's it for now. Okay. We take a break. Okay. We take a break, and then when we come back, we're going to actually bind this to your drone. So if you didn't do what I was showing you on screen, please do it on the controller, and then that way we're ready to go when we're back. Which about 4:20 right now? 4:35. If that works, yeah, 4:35.
Also, it takes
Okay, let me show you what the deal is right now. For those that are building the kit that they keep, here's the issue. We have our VTX antenna right here. And you see, they gave us a part that you're supposed to put the antenna through. That's what this little cylinder is for. but it's offset. You see that? So like you would have to severely bend this thing to get it to go through this. So I'm going to redesign this thing with the opening here instead of here.
It actually won't even go through the tube because
That's the other problem too, yeah. This tube is also too small for the plug to go in. So that's another thing we have to consider. So I'm going to show you my steps on how we're going to redesign this and 3D print it. Okay. You can feed it in from the top, but the problem is if you look at the actual plug, it's still too big for the opening. So we're going to have to do a couple of changes on that. Okay, so this is the existing thing that we have. And if you look here at the board, this is what we're going to try to redraw. The main difference is instead of this being on the outside, this is going to be on the interior now. So these are the four main holes that this will slip over the pegs. We had to get the diameter, so 4 millimeters. That's going to be all 4 pegs. The distances between the top two is 20. The distances vertically here is 41. Distances horizontally between them, 16.
Gigahertz, yeah.
And then D4 is the distance from this to the antenna hole, 8.5. The antenna shape itself, the plug is 4.5 millimeters by 7.5 millimeters. So I'm going to have to make that shape for us to slip it in. All right, let's go on to here and actually start drawing it. So this is, I'm going to go new. All right, this is the general procedure on how you draw something. Well, first you have to kind of sketch it out like I did there. Let me actually take a photo, and then I'm going to pull it up on the computer. Okay, so we need to draw it out in the orientation that we want this thing to be. So it's going to be like this, right? It's going to be flat. So which face does it make most sense for us to draw it on? The front, the top, or the right face? The top face, yeah, because we're going to be looking at this down, right? So I'm going to go here, create a sketch, and these are the different faces. So I want my top face. This is what we call the datum point. This is 0, 0. Now, what do we want 0, 0 to be? Well, on this drawing, you could put it here, or here, or here. It kind of depends on like what's the most important like defining feature for you. So I wouldn't put it here. That's just kind of like some random peg. So, I might,
Make sure you buy one with the cord.
I might put it like, maybe I'll just put it right here, right in between. You know, you could change it later, but it's kind of important to choose it from the beginning. All right. So what I have here is there's like these inferences. So like as I move along this horizontal line, it thinks, oh, you want to stay on the horizontal line? Okay. So it's going to snap to that position. So I'm going to go here. Okay. And I'm going to draw this. What I'm going to do is I'm actually going to create a parameter. A parameter is like a function. So right here, I'm going to say the name is top, or I'm going to say post diameter. Okay? Post diameter. And, dang it. These are parameters. Post diameter. It's going to be, what do we say? 4 millimeters. Okay, there's a post diameter, and then we want a thickness to this thing, right? Because this needs to slip over the post. So actually, I need to measure this as well. We're going to find out that the thickness of this is at 1.7. Okay, so I'm going to say sleeve thickness. 1.7 millimeters is our sleeve thickness. Okay, D2, it's going to be vertical post distance is what? 41. Horizontal top post distance is what? 20.
as you're creating this, it'll just reference that, and you don't have to try
Yeah.
to put that value
Yeah.
in.
So what's nice about this is like later, you can like communicate values like, hey, I just remeasured post vertical distance is this. Instead of saying, you know that distance between these two things, like I need you to change it to this. Like when you have user parameters, it's a function like in math, I can recall x equals something. So that's what I'm kind of doing right now. This is like, you don't have to do this. You can put in a raw number, but this is just to keep things nice and organized. This is like,
Best practices.
yeah, this is best practices actually. Bottom position post distance. Okay, what is it? 16. What else do we need? We need to have a parameter per antenna vertical post vertical mount distance. And what is it? 8.5? Is that what it says on here? 8.5. Now these have specific naming conventions, so it looks like they don't accept any spaces. 8.5. And finally, we need to have the antenna width is what? This is 4.5. All right, excellent. I've defined those features. So here I'm going to, let me just draw out the general shapes, and then I'm going to dimension it. So whenever you draw something, you have to go in and constrain it. Why? Because right now, I have not defined the size of this thing. I have not defined the position of this. It's free floating. It is an under constrained drawing. It's ambiguous right now. But right now, I'm just going to draw the general shapes just to get it out there. And then we will worry about the actual size of things. So I drew circles so far, right? I'm also going to draw a rectangle. With rectangle, there's multiple ways you can draw it. Normally it's corner to opposite corner, but I can also draw a rectangle from center to outside, which I rather do, because remember, I'm working off of this center line. That's going to be nice and easy for me. Okay, when you see things in blue, that means it is not constrained, right? Look, I can move this thing all over the place. I can make the size different. It's not constrained. Let's start to constrain it. We have two different things. We have constraints. This is geometric constraints. Things parallel, things concentric, things perpendicular. Always do this first before you put numerical constraints. So, what makes sense? This circle we want to be on this line, right? So what do we call that? What constraint would make most sense? Here's our options. Here's what I'm going to do. I'm going to create what we call a construction line. A construction line is a line that you use for reference, but not actual edge. So how do I do this? I'm going to draw a line. So now I'm doing a line tool. Why the heck is it doing that? Okay. I'm doing a line, and I'm going to make this distance, what did we call this previously? Horizontal top post distance to 20 millimeters, right? Except I'm only drawing half of it. So let me do that divided by 2. You see in here, you can do math in here. So I did horizontal top post distance divided by 2. It makes it 10, right? 20 divided by 2 is 10. Okay, now that I have that, when it's a solid line, that means it is an edge, but we want it to be just a reference. In our actual part, we don't have a horizontal line right here. So I'm going to go here into the sketch palette. I'm going to go to construction. That's going to turn that solid line into a dotted line. The dotted line just tells you it is a reference sketch. Okay, notice how the line is black. That means it is fully constrained. versus this blue one is not fully constrained. Once it turns black, then it's fully constrained. Okay, how do we get this? What geometric constraint do we use to put this onto this point? If you know the terminology, I know I haven't introduced it, but nope. When you have a dot touching a dot, coincident, that's what it's called, okay? So I'm going to press these two dots, so I'll slowly introduce them as we go. That's coincident. That is saying I want you to overlay both of these on top of each other. Take a look. Coincident. Now I've defined the position. I haven't defined the size though, right? The size is not defined, but the position, I can no longer move it. So let's give it a size. I'm going to go to here, dimension. And what was the name of it? The function? Post diameter. Boom. Done. And it's defined. Now it turned black. Notice that? Both the size and the position have been defined. Let us do an offset. An offset is going to be following that outline, but offset. How much do we want to offset? Well, I have a sleeve thickness, right? Again, I could have put in 1.7, but I made all these parameters. So now it offset that, just like that, okay? Because what we want is this ring. That's actually what we want to 3D print, just like you see right here. Okay, let's do the same thing on these parts, which I drew obviously way too big. What is the dimension I want to give this? Post, diameter, done. And then I'm going to, once again, I'm going to offset it by how much? Sleeve thickness. After a certain point, you don't even have to keep track of the numbers, as long as you know what you called it. Wait, why does that look wrong? Something is off. Post diameter. Okay, yeah, that was off to begin with. All right, so this is blue. So why? Because the position is still not constrained. Well, let's put this, let's give it some dimensions. So we know that from this point, vertically, it has to be how high? You can call it the number if you don't remember. Okay, so I probably call it vertical post distance. This would be 41. I'm not looking behind me. Is it 41? D2, 41. That's, you see my dimension right now? Okay, so I put that there. It's still blue because even though I wait, why the heck? Vertical post distance. Okay, so even though I've defined the vertical, I've not defined the horizontal. So you see, I can move it horizontally. What is the horizontal? What's the number?
D3?
What is the number?
Which one are you doing?
Here, I'll show you on the computer screen. From here to right here, this one. I'm doing this.
Oh, 4 millimeters?
That doesn't sound right.
I don't know if I don't think I'm working it right.
Huh? 16. Sorry, my bad. Richie, look what we're doing. We're literally 3D modeling. Okay, so I'm going to call it, he's in my other 155 class. Horizontal post distance right here divided by 2, because remember, I'm only drawing 1/2 of it. Boom. It's black now, okay? We got these two posts. Something doesn't look right here. Proportionally speaking, this doesn't look like that. Something's off here. Let me double check here. Right? Look at this thing.
Yeah, they're
Proportionally, something's off.
more acute of a trapezoid.
Yeah, we are redesigning this thing because... No, I'm not talking about the trapezoid. I'm looking at the circle. Look at it. Look at the circle part and look at this. It looks like the wall thickness is way too thick. Okay, let's go ahead and change that. Here's the beauty of me assigning it to a parameter. I'm able to change it right here. I think it should be 1.5. And it's going to change everything that I referenced previously. I'm just going to trust the numbers. It doesn't look right, but maybe this is like one of those optical illusions. I guess. All right. Okay, so now we have the shapes are black. We're not done yet because we still have to draw this antenna one. Help me through it. We have this square right here, this rectangle, and we need to get this to the right size. So what do we need to do first?
You want to constrain.
Geometric constraints, right. So what are some things, because the position is all over the place.
Yeah.
So how do we constrain this?
Is your up, down, is that your Y? Right
Yep.
now? Yeah,
With?
So I would probably start by constraining the Y
Two,
to the center point.
good. And
And
do you know the name we might be using it for?
Yeah, you want to do a coincidence.
Good. Oh, coincidences work. It should work. What the heck is going on? This plus this. Oh, why did it not? It didn't work.
It's probably a little constrained.
I think maybe this might. Okay, let me see here. Okay, I have another idea. This is another way to approach it. Okay, constraint doesn't seem to coincident.
You have to click on it. You have to constrain on it. Why do you have?
Yeah, this constraint is telling you. You see right here, if I click on it, it's no. These constraints are for these crossbars right here. Okay, here's another approach. This is actually Richie. This is a good one because I haven't showed this one. Symmetry. So what this is saying is, it's kind of hidden down here, but what this is saying is this happens to be symmetrical, right? So I'm going to put this line and this line symmetrical to, oh, we have no line here. This is just an axis.
Oh, yeah.
So let me create a construction line.
That was just a reference line.
Yeah, let me create a construction line. Okay, so I click this and I go here. Okay, I think the coincidence will work now because now we actually have. Oh, there it goes. That was not a line. It's just an axis. Okay, the other thing I was going to show, though, this is good to know. Because it happens to be symmetrical, I can go here. This with that. And that does two things. It makes it on that line, and it makes it symmetrical. See, look. When I drag this, it drags the other side. The other way, it would just keep it on there,
Yeah.
but you can still like maybe drag one side longer than the other. Yeah. So that's what's kind of nice about the symmetry. So I'm actually going to use that. All right, get me some dimensions here. What do we need here? This dimension, the width. What's the number supposed to be?
I think it's 20.
No, it's going to be this thing. 4.5.
Oh, are you doing the?
I'm doing the
antenna hole?
yeah, the antenna
Okay.
hole. Sorry, this is supposed to represent what I have in a circle there. My communication is not exactly
Yeah,
there right now.
4.5.
So I'm going to call antenna width, which is 4.5. And then the height is going to be what?
Is that 7.5?
Sounds right, which is antenna height, 7.5. Okay, there's our antenna height. Oh, it's still blue. Why? Before I move it, tell me what you might think is under constraint.
The symmetry
Yeah,
on
well,
the Y.
the height is already defined, so this cannot stretch anymore.
Yeah.
The vertical position. The vertical position is not defined. Look.
Yeah.
Yeah. So what is it supposed to be? I measured it from, on this drawing, it's from here
Center to center.
to here supposed to be.
8.5.
Okay, so I think I call it antenna vertical mount. Like that. Good.
This is satisfying.
All right, so we have to do an offset once again. Isn't this nice? I'm using the same offset for every single one of these. How much are we offsetting it by? I don't even remember, but I just remember I have a variable called sleeve thickness. Let's give it that. Okay, finally, I need to draw all these lines to connect things together, right? We need to have a rib to connect all these things. So let's do this. I'm going to draw a line from okay, here's what I'm going to do. I'm going to draw a line from here to here. This is going to be a construction line, right? We don't actually need this in reality. From here, I'm going to do an offset. Okay, so let's do offset once again. And this time, I'm going to do a bidirectional offset. because I want to offset from both sides of that, right? Okay, so how much do we want to offset? Sleeve thickness. Except I don't want sleeve thickness. It's going to do it on both sides that amount. I want to divide it by 2. So that way I get it to the same thickness as around the rings. Okay. Great. I have this. Don't worry the fact that it's like intersecting. We will deal with that later. All right, let me see if there's anything else. You notice, by the way, I'm only drawing half of this because it's symmetrical. I'm going to mirror this on the other side. There's no point drawing it double. Oh, we need to connect this to the antenna slot, right? So let's draw. How do I draw it from here to here? That's going to look beautiful. Or do I want to draw it from here to here? What's going to look nicer? Here to here or here to here? This is just more of like now. I'm going to draw it from here to here because eventually we have to somehow constrain this to the other side. So once again, I'm going to draw a line from here to here. I'm going to set that to construction. I'm going to do another offset. This time I'm going to do I think I'll do a one-sided offset. Yeah, I'm going to do a one-sided offset. Okay, maybe I won't make this construction. I'm going to unconstruction that one. What I'm looking for is all the blue enclosed shape. All these blue enclosed shape are things that I could potentially thicken later. So even though we have an open profile here, it should still work. This is going to be like still really unstable, so I think I'm going to have to put another bar around here. So let me just put another bar from here to here. You notice like there's a lot of inferences. If you look, there's like a little box with the X through it. Okay, I'm just going to purposely put it offset like this. And I'm going to go from here and here, and what do we need to use? What kind of constraint? What type of constraint? I need to get this to sit on that line. Coincident. That's going to be our most common one. Coincident, you see? Once again, I'm going to take this, I'm going to offset it. Offset by how much, yes? Sleeve thickness. Except it's going the wrong way. Well, no problem. We'll just go minus. Exactly. Minus. There it is. Oh. How do we get this to here? Which constraint? Coincident. Good. All right. That's looking pretty nice. Oh, we need to have another line that would go from... Oh, you know what? I can offset this. Beautiful. Because eventually, when we mirror it, we need to have it like the two bars need to meet. Symmetric, sleeve thickness divided by 2, remember? Okay. Look at the left half. It looks pretty good, right? I think it looks pretty good. We might have to have a bar across the middle because I think this is going to be too flimsy.
I don't know if mine is different, but on the bottom, it's starting, this side is starting at the middle of this hole, but then it looks like it's offset on the outside of the middle of the bottom.
Yeah.
Does that matter?
Yeah, that's just design. Yeah. It doesn't have to be, yeah.
Like a super tight tolerance.
But right here, this bar is going to be kind of flimsy, I can tell. So let's put another, even look at this thing. This has a supporting bar going throughout the middle, right?
Yeah.
So we're going to have to put another bar. Let's do this. I'm going to put a bar from this point to this. This is blue because it can be anywhere along here, right? So let's put this in the center between this and that. Okay, how do I do that?
Take the distance and set it at a half point.
Yes. I think there's a way you can actually do a... You can do a midpoint. How do we set this? What's that? Yeah, but the midpoint is between here and this point. That's what I want the middle. I want the middle, like this box right here, and this box right here. This is what I want this to be in the middle.
Can you draw, what do you call those lines that are just for reference?
Yeah, I could do that. It's like I already have one here. That's why I was trying to see if I could use it again. But what gets hard is that you overlay two of these. Here, I'll do it anyways. I'll draw it right here though. From here
To that midpoint?
to this point, yeah. But this one is not actually on that. Here, let's get this thing in between this and this. I need to do. Okay, that's not even an option. I might need to draw another construction line in the middle of this thing. It's getting messy. Okay, so this will have to be. I believe we can use symmetry again. Oh, no, we can't. I lied. Okay, maybe, dang. It's a little trickier, huh? I'm just gonna give it a hard number. This is against my recommendation. I'm just gonna give it a hard number. So it's not gonna be exactly in between. But, okay. The reason I don't like to use hard numbers is because later, let's say you change the width and stuff, it's going to stay at that same position. Whereas if you use like constraints and relative geometry, it will change along with it. But right now, I just kind of wanted to get it working. I'm going to make a construction. Let's offset it one more time. Symmetric. Sleeve thickness. Divided by 2. Boom. Just like that. Oh, this is supposed to be a construction. That way we don't have that blue area. Okay, so we have this. We have this shape. We have this shape. We have, the bar here. We have a bar here, bar here. Okay, I think we are ready to mirror. So let's mirror this with this icon. What do I want to mirror? It's asking for the objects. I want to mirror this, 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 this. I'm not going to mirror everything because ultimately the left side is still our original part. So whatever we make changes to the left side will reflect on the right side. Okay, I think that's it. I basically selected everything but the construction. Mirror line. We have to have a line, and we happen to have that construction line. Look at that. You see the preview? Looking pretty good. I'm going to finish sketch. Everything is black, right? Good. All right, it looks really messy, but it will look a lot better once we actually give it thickness. So what happens is you do 2D drawing, 3D action. 2D drawing, now we're going to give it a 3D action. What is a 3D action? We're going to thicken it. We're going to call it extrude. We're going to make it rise out of the page. It's going to ask you what profiles do you want. So I'm going to say this profile. I want that. I want that. I want that, that. You see, that's why I was saying it's okay that it's kind of like free floating. Some softwares are more picky where you need to have enclosed shapes. But this software is actually pretty... this software is called Fusion. It's free if you're a student. That's why I'm using it right now. It's pretty good, actually. Yep. Autodesk Fusion. It's free as long as you have a student email address. So... Actually, all of Autodesk software is free. Yep. Autodesk Fusion. If you have to look up Autodesk Fusion educational license, okay? And then you can, you just put in your school email address, and it'll work. All right, let's continue on here. I do want that thing. I want that. I basically want everything but the interiors, right? Does that look right? That looks pretty good, doesn't it?
Yeah.
All right. Let us give it a thickness. How thick do we want this? Well, I already measured it. I said it's 7 millimeters. Oh,
Do a prototype and
did I? You're right. We're gonna do a prototype. Good. So Sean brought up a good point. So 3D printing takes a while. This thing is probably gonna take like, okay, these printers are slow. I don't know what's up. This thing is probably gonna take like 3 hours to print. Like, so just so, since it's already 5:30, just so we have a general like fit check, I'm gonna print a 1 millimeter thick. It's gonna print in the 1/7 of the time as, you know, the full thickness. So let me just make it 1 millimeter thick. And here it is. Look at that. Looks pretty good.
So when you, if this works and you like it, when you go back, would you change, would you?
I'll make it full
any of the
thickness.
support structures to mimic?
I'm just being lazy. Like, this actually doesn't have a full height support. You see that?
Yeah.
I'm being lazy. I'm just doing full height supports. You can do that, but then I have to go in and make additional cuts and stuff like that.
Yeah.
But just for simplicity, I'm doing this. Okay, let's just do a sanity check. I'm gonna come in with the built-in caliper and let's measure some stuff. So in Spec Tool, let's measure the diameter. What do we got here? 4 millimeters. Let's measure from diameter to diameter. What do we got? 20 millimeters, is that right?
Yeah. I mean, it corresponds with the drawing.
Okay. Just double checking. Here, it's going to tell you the shortest distance, but we want to know coordinate system right here. You see that? Along the y delta, we have 41 millimeters. Okay. Let's go from here to here. We have, along the x delta, I have 16 millimeters. You see that? 16. Here's the coordinate system in case you're wondering. X, Y is vertical, and Z. Yeah, so I mean, this should be right because, like, you know, this is useful for perhaps you have assemblies and you're trying to figure out how far things from each other. But ultimately, if you want to see something, you just go back into the sketch and you like look at the dimensions you put. Down here is the timeline. So this is kind of showing you what has happened in progression. So we only had 2 steps. One, we drew a sketch, which is hidden, but here it is. And then 2, we made an extrusion. So later, let me show you something else, like something like this, for instance. This has multiple progressions. First, I drew this outline. I did the same thing. I drew a half sketch, then I extruded it, and then I mirrored it, and then I filleted it. You see these little curves right here? I filleted it. And then later you can go into here, and I actually have a whole simulation. I need to rerun the simulation, but let me see if it's done. But you can run a stress simulation on it. This is like getting into a lot of different details.
Okay, that computes on the cloud instance?
Yes.
Runs locally.
So you can see right here, I put the forces right here, and then this is a fixed point right here. So my factor of safety, I needed a 4. Like my range is 2 to 4, but I have a 40. So it is over-engineered actually. This is like way too thick than it needs to be. This is like, you know, very important if you care about weight, which I guess for a drone you kind of do, right? So this is way too thick for what I need, but I just designed, I over-engineered it just so I know it's not gonna fail. This is actually like a bike lock, a U-lock shackle thing. So I have a rack here,
Yeah.
and I put that on the rack, and then I put the U-lock on the bigger one. Yeah. So anyways, you want another one? Yeah. It has to fit your U-lock and it has to fit your rack though. This is specific to my rack and my U-lock. But it's easy, right? All I have to do is, if I want to make it for you, I go into here and then I could change the parameters. So you tell me the diameter, you tell me the width, and then I can change it right there. And then,
You can define the materials.
yes, you have to define the material if you're going to do a simulation. So right here, I go to modify, and I go to physical material, and you see right here, I'm using plastic as my material. If you have like a 3D printer, you can go and you could use ABS, PETG. This is what we call, this is TPU. So I don't even know if they have that, TPU. No, they don't. So you would have to probably find something similar, or if you really need accurate, you need to put in all the tensile strength and all the other stuff, material parameters. That gets into like, that really gets into the weeds. Yeah, that's like a whole different, that's a whole course on its own. Okay, so I'm going to save this project. This is a drone project. Let me just call it, what is this drone called? What's this drone called again? Sky, whatever?
Sky Galaxy.
You have the box. Can you see what your box says? Sky Star. Okay, I lied. It takes more than 10 minutes. Alrighty, let's create a new folder. And new folder. Sky Star. Alright, I'm gonna call it VTX antenna. Okay, this is the next step you have to do. Is that done or is it still printing? 52 minutes? Perfect. 52%? Damn, okay, alright. So this next thing is we have to take this model and then we have to put it into we have to process it so that the printer can actually print it, right? Just because you drew it up doesn't mean you can actually like make it. That's one big disconnect in engineering is people draw things, but you can't necessarily make it. All right. So I know we can make this thing because it's very like, it's like in one dimension that you extrude it. But if you start extruding things that has like internal canals and stuff, it's like, well, how do you hollow out the inside? You know what I mean? Like you have to think about things like that. So what we have to do is we have to export this. This is a proprietary file that only Autodesk Fusion can process. A 3D printer can't read your 3D models. So we're going to, it's the equivalent of like saving your Word file as a PDF. A PDF is a universal file that a lot of devices can open. We're going to go to File, Export, and that universal device the file that we're going to use is called an STL. Stereolithography, I believe that's what it means. Okay, so I'm going to export it. Okay. And then I'm going to go into a program called Ultimaker Cura. This is a free program. This allows you to import your printer parameters so that you can actually lay it on the bed in a specific position. You can set the type of material you're using, how the quality of the print is, and all sorts of things. So here I'm going to take this part, I'm going to drag it in. There it is. That's how it's going to look in our printer. The material I'm using is, we got loaded as tough. And you better like orange, because that's all we got right now. All right. Hey, actually it works out. So we lucked out. The orange is orange, okay? So I'm going to do that. In terms of quality, I'm going to do a really rough quality because I'm just trying to get it to, I'm just trying to get a prototype, right? We just want to make sure this fits. Next step, we're going to slice it because this printer prints in layers. So that's why we say slicing. Literally 7 minutes. Okay, this is good. We can still get a prototype today. Okay, because this printer is offline, we have no way to actually send this to the printer. Normally, if you have this printer at home, you can connect to a home network, and then I can send this to my printer. And not just send it to the printer, you can also monitor the progress, but you need to connect it to a network. Let me show you what's going to happen on the printer. It's going to print, it looks like 9 layers. Here's the first layer. It's setting the baseline. Then it's going to lay down 1. Oh, it's actually only like 4 layers. Layer 5, 6, 7, and 9. So it's only like 5 layers that's printing. So this thing is going to be super thin. But again, we don't care because this is just a proof of concept.
Yeah, and then for the final one, you might change the infill pattern.
Yes. There is no infill right now because it is so thin. there's literally just already have the 2 wall layers is already, yeah, if it was thicker, there would be an infill. I'm going to save to removable drive, the one I just plugged in. Gonna take 7 minutes and 2 grams of material. Just to give you an idea, this material generally costs $20 for 1,000 grams, a kilogram, right? 1,000 divided by 20 divided by 1,000 means that it is 2 cents per gram. We're using 2 grams. This is a 4-cent part. Granted, you have the printer itself plus electricity and well that. Anyways, this part has, I'm gonna have to go off. The material that we're using is called PLA, polylactic acid. It is a very common 3D printing material just because of its low melting point, good for printing, and its affordability. So you're going to find that for a lot of general purpose parts. I mentioned TPU right here. This is what you have for the ducts because things that might be good to be flexible, you have TPU. We also have even more expensive printers standing right behind you. That is 10 times the cost of those at $70,000. That printer, the reason, I don't know why it's that expensive, but I will tell you that printer can print something really nice. Let me get the part. Up, we have a finished. Oh, you guys that built the classroom drone? You notice this part? Some of you guys are missing. Well, look, I 3D modeled and 3D printed this. Okay, so you can come and grab some up here. I also want you to take a look at this part right here. Go ahead and compare the two. All right. First, try the orange one. That is just your standard PLA, and then try this one. Try bending it. Black piece, $70,000 printer. Orange, $7,000. Now, it's not the printer that makes it stiffer. It's what the printer can do. That printer is called a Mark Forged X7. If you look at this printer, it can do carbon fiber inlays. That is why it is so stiff. Is you can actually put in strands of carbon fiber into that.
Yeah, I got an idea.
So, no, that actually all happens on the post processor, just like this. This is where you define, hey, which layers do you want your carbon fiber, and yeah, exactly. How many layers you want?
It has multiple nozzles.
Yes, that has multiple nozzles.
It's
As well.
still PLA.
It can still do PLA, but when you embed it, then it gets super stiff.
Is the black one PLA exterior and then?
So they use their own proprietary thing called Onyx Black filament. So I don't know what it is.
But the carbon fiber is its own spool.
Yeah, it's a spool. You can see it right there. It's that one that's in the glass. It looks like it's it's a composite material made of nylon with chopped carbon fiber. So here, feel this one. This one is Onyx without the carbon fiber. Just to give you an idea, without the actual carbon fiber strands.
It's more flexible than the.
Yeah, because chopped carbon fiber it's not gonna hold the rigidity. It's all like broken. So the chopped carbon fiber is not that much like stronger. It's actually kind of weaker than this.
Yeah, it is.
But anyways, So yeah, there's different types of material that you can choose. So a lot of considerations. We also have here what we call support material. So actually, I just took this out of the bucket. Let me show you the difference. So right here, I have a part that needs a very nice smooth groove. This is a dovetail notch. When you print this, if I print it like this, you can't print on air, right? So it has to do what's called support material. It has to print this thing that you temporarily have and you have to scrape out. Well, look at this. This is so difficult to scrape out.
Yeah, you can't, and then.
Yeah,
you're gonna, like,
and then
hand
it's
clean that
horrible.
out.
Yeah. On the other hand, you can do what's called a support material. This you print, and then you put it in a bucket of water, and it dissolves away. Yeah. So that's how I was able to get this part a lot nicer finished than that one. Yeah. But you need to have a printer that can do 2 extruder heads. So these are different considerations.
What is this?
That is the water soluble material that just hasn't been dunked in water.
Is it like sugar or something?
I don't know what it's made of actually.
I just thought we'd bring up the spool here.
Oh, thank you. Yeah. So I mean, it looks just like the other one. They call it PVA support. So let me look up PVA plastic. PVA is polyvinyl alcohol. So water soluble synthetic polymer. Structure. Let me see.
Oh, that's what
Because-
they use in the laundries.
Yeah. So let me see. Right
Laundry
here.
pond.
So this is. So when, I mean, if you guys know a little bit of chemistry, so water is a polar compound, like dissolves like. So if you have a polar compound, that then it will also dissolve in water. But anyways, now this is going into chemistry. But polyvinyl alcohol.
Bad for your skin.
Yeah, there it is. So it looks like, oh, it's actually a alkane structure with alcohol substituents like this.
See you last Thursday?
Yep, see you class Thursday. All right, so that's our crash course. I have a feeling we might want to thicken this up. I don't know, but we'll see once that is started. Okay, so it'll be done in another like few minutes.
Do it individually because you can't recall your.
Yeah. So here's what I'm gonna do. So the issue is the holes in the reality after we printed it was slightly smaller at 3.6 when it's supposed to be 4, so it didn't fit. So I'm just gonna do a little bit of prototype top plane, and I'm just gonna draw. I'm gonna draw a couple of rings, and let me offset this. I'm just using numbers now. 2 millimeters. So this is what's our first one gonna be? 4.2. Okay, finish sketch, and I'm going to extrude it by, let's make it 2 millimeters thick. How about that? Okay. Let me file export that. I'm gonna call it an STL, and I'm gonna call it 4.2 millimeter diameter, right? Now I'm gonna go in here because I don't really care about these parts, so that's why I'm not like making new ones. I'm just editing 4.3. All right.
Is it better to do them separately, or do you also do all 4 on the same project file?
So when you make a project file, you want to make it per independent part. So if you later you're gonna take all these and you're gonna assemble them, they need to be as like a separate part. That would be my guideline. Right now I'm kind of lazy. I'm doing it lazy, and because I don't care about these parts, I'm just overriding them every single time. But yeah, generally you want to like you want to do them per individual project file. Yeah. File export 4.4. Okay, finally we want 4.5, right?
Yeah.
Oh, this part?
All right, that should be enough. Export. What's? Yeah. So remember, all I did here is I'm making the part. Now I have to go into Cura and I actually have to lay it out. So those were all independent parts. So I'm going to take this, I'm going to delete it. I'm going to go into here, I'm going to make those parts. I'm going to go here, and there they are. They're lined up. Shoot, I don't know which one's which anymore. Oh. Okay, here's what we'll do. I forgot which one's which. Okay, we're going to drag in one. Let's drag in the 4.2 first.
Yeah, and just line them
there's that. But
Can they like overlap in Jira?
they can, but it's not going to let you print. It's not going to let you export if you. Okay, so here's the front of the. Okay, so I'm going to line them up like 4.2 on the very left, and then 4.3 to the right of it, and then 4.4 is going to go right here. Okay, there it is. So that's how we're going to line these things up.
I have one question. How strong are these propellers, and will they just lacerate you, or will they chop your finger off?
They will not chop your finger off, but they'll cut you pretty good.
Okay.
All right, so here, I'm actually going to purposely offset this one. So that way we know. This is the 4.2, 4.3. Let me make them even closer. When you close the gaps, this is such a small print, it's not going to make a difference. But if you close the gaps, the printer head travels less, which means you have a faster print, right? So, okay, 4.2, 3, 4, and 5. Let's slice this and see how fast. 5 minutes. I thought it would have been faster, considering like we're literally printing nothing compared to the other one. You know what? If I put this in line, because of what I just said, it might actually be faster. Let's slice it again. It's still 5 minutes. I'll put it back here then. Put it back here so at least we have a better indication of our orientation. Okay, I'm gonna save it. I'm gonna eject this.
Do you have a smoke stopper?
No.
Yeah.
Can someone start this for me? Did you watch what I did? Can someone start this?
It seemed like you plugged it in and then you navigated.
Yep. All right, go ahead and do that.
Dude, you need a smoke stopper?
Yeah, if you wanna help me use it, I don't know how.
You got a battery?
And I don't know which battery to grab either.
I got one.
I'll be honest.
I'm printing at high quality. This is fast quality.
Yeah.
It's like a cheap one.
How you doing, my friend?
I have a
Richard, right? No, Sean. That's Richard.
like
Yeah.
I have a
I'm gonna have to, stick these wires in this, heat shrink.
really thick one.
Oh, that just goes to the side.
Yeah, I don't think this would handle it because it's so heavy. Like if it like shakes around, it'll probably break. It'll probably break the. Yeah. Oh. All right. In the meantime, we're gonna thicken this. What do we want to thicken this original drawing to? So I have here the original drawing. Let's thicken it back to what was this supposed to be?
7.5?
7.5.
I think.
7.
7.
All right, that's how it's gonna actually look like.
Ooh, yeah.
Okay. Once we get this final.
Did I solder some things and it turned on?
Once we get this final dimension check, then I'll go in here and change it. All right.
You'll update your.
The diameter, specifically the variable. Yeah, the parameter.
Yeah.
So I don't have to go in, see the power of the parameter. I don't have to go in and edit each and every one of them. I could just go in here. And I'm going to change this number right here, post diameter,
Yeah.
to whatever it's supposed to be.
Will you update? Will that automatically update?
That'll update everything. That uses that. That uses that. Yeah. Okay. In a moment, we will be going back to the controller. So does everyone have their drum out and their controller? You create a new model.
Yeah.
Let me just take a look here. I'll make sure we're all on the same page.
5 wires? What?
DLRS.
Nice. Thank you.
It's in the box.
Oh.
My drone didn't blow up, we used the smoke stopper.
Oh, nice. Actually, that is something I need to put on the shopping list. I need to put.
So if we have one charged up, just give it to you if we're not gonna use it?
Like what angle?
Oh, what?
You're not going to use it with your drone?
We have one here. We don't need two compared to the same drone.
Oh yeah, you don't. Just put it back in the box it came in.
Oh, per my,
And you can put it back into that.
per my, just idea, I think we should only use,
I would say 50. Yeah, I need at least like 50.
water soluble.
What's your idea?
Because when I was using the rosin flux, I don't know if this is like a different type of, but it would not come off. It took 4 of us just to desolder it. Yeah, solder it. So, but this water soluble, man, it plays with you, it does everything you want.
I thought you said it was hard to work with.
I thought, but I was, I was incorrect. That rosin.
Okay.
Yeah, rosin. It's horrible. Per newbie. No good. Water soluble. Please. If you want to de-wit and desolder things,
Basically,
because after that, when that rosin goes on, it's a brother right here. It's a Allen. It's a freaking Ryan just to get the solder off. Also, my tip might have been too small.
Did Ryan end up getting it like the 3rd time after like the 2 times I got it?
Yeah. He bridged it again, but it was slowly scraping off.
that's where the TPU is nice. Is like if you're off a little bit, it will like slip it.
Yeah.
Whereas the hard plastic you're doing, it has to be like exact.
3 of them. It had 4 already assigned, and then we added on.
All right, let me see all.
Could I, how would I find out if that my ELRS works to my remote?
We're doing that right now. So I'm about to.
Here's an example. Here's the 915.
Where's your remote? Are you using the classroom remote?
I'm gonna have to, right?
Yeah. Okay. So actually, Jason, do you have your classroom remote? He can use it.
Oh, yo, I forgot to tell you.
You want him to,
Sorry.
I let him borrow.
I can't wait. Could've been
Oh,
Yeah, he's using it.
I finally got a new backpack come in.
Or you
No,
guys
I-
sharing it?
This thing is
I was
trash.
Yeah, they were sharing that one.
So where's your controller?
I gave it to him to share with him.
They're gonna share it.
Okay, so you
So he can use that.
I went with the RD keyboard. Because I was talking.
Nothing's been a problem.
I might still
But it's charged.
Okay. Thanks, brother.
But I was, and because I was talking.
You know what?
He said he was still gonna give me
I have a box right here. My other one, fine.
Oh, ours is down here.
Travel somewhere.
You don't have the rudder.
I mean, this little thing is perfect. 'Cause I could fit 3 drones on this thing.
And as far as all the other
go with-
packages, the other one has a
Well, it's a universal slot.
We don't need those spots.
So if I want to take like, so if it's like.
No, we got the box.
That's the biggest thing that's bothering me with my setup right now. My setup isn't very.
Plug it in, which I know is not gonna be a problem because.
Yeah, it's not very ripped, right? But because I have all that bullshit.
All you need is a transfer.
If you plugged in.
Oh, you don't have the
We're checking the cards.
Yeah,
You have a plug in a battery.
So we have this, I think.
The idea is you're supposed to use a smoke stopper
In and out,
with along that battery, just in case there's a bad like connection. So then so have you been able to connect to data plate?
Yeah, but once you have the source.
You're getting it. I know you're working out, I heard you, put in work.
Oh, is it multi-engine?
For a pilot. For a pilot.
He is?
So you're telling me? Damn, oh, yeah, he's a pilot.
I'm just fun.
They have the pump basically all set. Let me get them.
I'm sorry, what?
So bad.
Oh, the Thompson? Yeah, I was like, what plane is that? Oh, that's up in China.
hit the switch that we want to use it.
Yeah, I was like, how do you fly that? Yeah, well, yes, and, it works different.
Your radio set up?
No,
You
I
used to set it up already?
No, I forgot.
Do you have a radio?
Does that make sense?
Do you, is it a regular? Okay. Do you?
No.
Once I in a bit, once we confirm the diameter, I update the size, we'll start the new print. Then
It's useful for.
we will jump into this. How many people have the custom or not the personal drone?
I have a personal drone.
I need to see how many to print of these things. You have one?
How many people have a personal drone they had to solder with? Drone you had to solder with.
Wait, but yours is different. The ones in the classroom kit.
Oh, yeah.
Who has the classroom kit that you bought for personal use?
Classroom kit
One.
solder.
One? I thought there was. Okay, then.
Oh, there's
Ryan has one too.
There you go.
Right, but I thought there was like another person sitting here that had.
4, 5.
Oh, and my brother right here.
Can you just hold up the drone?
That
That drone? Who has this drone?
Oh, I got that.
So 1, 2, 3, 4, 5,
6.
6,
Because-
7.
Find out how many you can print.
Yes, 7. Yeah, I'm just gonna print 10. Screw it.
He said 2 cents.
But that's for like.
Whatever. Yeah. 2 cents was for the 1 millimeter thick part. This is gonna cost us maybe 20 cents this time. Woo! Killing me, man. What?
Amazon Inc.
Yeah. Hey, have you guys seen that some of those places like fast food, they don't even take or give pennies anymore?
Oh, yeah.
No, because the U.S. The mint stopped making pennies. So whatever you see in circulation is what we got.
It slows me down and I just.
Oh, really?
Like flare.
Oh.
I'm out of here, man.
See ya. I mean, I seen those things where it's like take a penny, leave a penny, but that was like a long time ago. I don't really see that anymore. Hey, is the print done? Oh no. I was like, man, that thing should have been done a long time ago.
I'm ready to set up this controller.
All right, I kind of went
Usually
over
doesn't
that,
say in the
so
model too, you have to program.
I think we might have to follow along with someone else, and then we will. I'll come back. Okay. So. All right. So when you bind the receiver, you only need to do it once. Once it talks, then it's good. All right. You can bind multiple drones, or specifically, you can bind multiple receivers to the same transmitter. However, you can only use it one at a time. All right, so you can't be flying multiple drones at once. All right. Now, there's multiple ways that we can bind our receiver. Not all of these are options that are available. It depends on your hardware and software and such. Method 1, in Betaflight, there is a bind software button, but that is only available if you have a high enough firmware on your receiver. I'm going to skip that one for now because I don't think our thing actually works. Here's how you can test. Actually, if you have... Oh, I should have just plugged in the drone myself. Robert, your drone is plugged into Betaflight. If you go to... I don't even know what page it's supposed to be in.
I think that's the way they did it on the tiny.
Here, let me plug in a USB and let me see what the heck is going on here. Okay, so I'm actually just gonna go over and. All right, so I don't think this is actually an option for our drone, the classroom drone. You said you found it for this drone?
No, for my tiny.
Oh, okay, all right.
But this is the method that I use.
Right. Okay. So we don't have that as an option. Method 2, I should put these later because that's also not really a common method. if you have a physical bind button. I mean, most of these receiver, look at your actual receiver. There's probably not a button on there. It's like, yeah, so. Okay, method 3, we're going to enter a bind phrase. Okay, this is going to be your recommended method. Bind phrase is kind of like, it's like not really a password, but it's like, hey, I'm only going to talk to someone that has this name tag. Bind phrase is something you can create. So you would have to set a bind phrase on your receiver and then set the bind phrase on the radio as well. They need to match, and then they will automatically connect with each other. All right. And the good thing about doing the bind phrase is that if you have multiple drones and they all have the same bind phrase, then to the same as your controller, then they will automatically connect. Or let's say you get a new controller, you could just set the bind phrase to what your drones already have, and they will already automatically connect. You don't have to go and bind it every single one. Okay, to set the bind phrase, I guess we can set either one right now. Let's set the radio controller bind phrase. Okay. Sorry, we interrupt to go back to this because we found out 4.3 is actually what we want. So I'm going to do post diameter to 4.3. Okay, I'm going to save this as a... I'm going to save this as a STL again. Export, replace. Okay, this time we need to fill this plate with at least 7, right? So I'm going to go here.
So did you say you extruded and then updated?
Yeah, I updated it right here. Wait, this time isn't right. Let me go here. File, export, STL, export. Yes. Export complete. Oh, there it is. What the heck? 805. No. Why does it say 540? Okay, you know what? Just to be safe, I'm gonna save it as a different name. Antenna 1. Okay, I'm gonna save it like that.
Yeah, this one kind of a
Oh, there it is. Okay, we're gonna grab it into Kira, and we want at least how many copies? Let's do 9. How about that? Looks good? All right. This time we're going to slice at a higher quality. So the layer height between layers, I'm going to say 0.1. I'm going to slice that. And it's going to take 7 hours and 41 minutes. And that's why I want to do the little quick prototypes first. Let's make this thicker overall. Here, let me just see. Slice. There's going to be no infill because it's so thin that it's basically going to be a solid part, which is fine with me. So there it is. It's going to rise up out of the ashes like that. Yep. All right. Can you set this printer to start once it saves?
Saved.
Checked. All right, here you go. Oh, sorry. Okay, now we're going to try to set the binding phrase on this thing. So this thing has built-in Wi-Fi. Actually, let's do the wired method. Just take your wire, and we're going to plug it in. This time we need to plug it into the top port. And then I'm going to turn on my drone. All right, I'm going to turn on my controller, okay? When I turn on the controller, it's going to ask you... shoot, this one's probably not charged.
But did you plug the controller into Betaflight? Sorry.
We're not... Oh, actually it is charged, sorry. I'm going to turn it on. Let me do this. I think you maybe have to turn it on first and then plug it in. Okay, yeah. I should have showed this on the screen here. Let me. Oh shoot! But I have this plugged in. Oh, okay. I don't have enough USB ports. I'm using up all my USB ports here. All right. Let me show here real quick.
Type C to USB if you need it.
Oh, I'm good. I ran out literally on my computer. Like I don't have any more USB ports.
Oh, and one other thing, I wanted to switch my
What the heck is going on?
my roll and
Your
yaw. I wanted to swap them. Yeah.
Okay, let's see if we can get to that today. Let's see if we can get to that today.
I thought I would want to switch it, and then I started flying, and it.
Okay, so if you look here, I turned on the radio first, then I plugged in the USB, and I'm plugging it into the top right here. You're going to get 3 options. Joystick, this is what you want to do if you're going to use it as a simulator. USB storage, that's what we want right now, okay? Okay, I'm going to say allow. Okay, so what's going to happen is if you go here, and then it will actually show up as as 2 things on your removable drives. It's going to give you a no name. There's an SD card on this thing. If you actually look at it, on the top, on the right side, there's an SD card. Right here. That's a black SD card, okay? So this is actually what we should do before we start to modify or update any firmware, is you really should back up your models. Look at here. We have our 2 models. I don't know why the name doesn't reflect what we called it, but we have our models, or you could just back up everything on here, just in case something goes wrong. So maybe I'll do that just to be safe. I will just back this up. Okay, so I will go and I will just back up. What is this called? The Zorro? Okay,
Yeah.
so let me just back up the model. What else do I want to back up? Yeah, I'll just back up the models. That was the things I just set up, right? I don't want to do that again in case something goes wrong. Okay, I backed it up. All right. Now, we have our other thing, the Zorro right here. That's our firmware. Okay, we're going to actually check. If you go to the radio itself, let's see what firmware we have. I'm going to go to sys right here. Oh, what the heck? Oh, I guess I can't use it while it's plugged in. Okay. All right, I'm going to eject both of these. All right, fine. Okay, maybe you just have to unplug it. It could.
Just don't let me forget it.
Oh.
All right, whatever.
So you can do that, just unplug, you don't have to eject.
Yeah.
Flash memory card, you don't have to do that.
What's that?
You don't have to eject it like
You
you
wanna
would
come
like
over here?
That's what I was trying to do, but then it came back online again. I was like,
Are you trying to?
okay, I'm gonna go to
combine this
sys.
yours?
I have no idea. Is that what I'm doing right now?
I don't think.
I
that
just-
Okay,
I don't
when
think
you are on page 1,
because that's
tools.
TLRS, and that's.
This is the page for the system. This is how you know it's for the system, not the model, because you see it's out of 7 pages, 1 out of 7. Okay, when you're on the tools, you want to see if there's something called Express LRS. Do you see that? Do you guys all have Express LRS? If you scroll around on page 1.
Yes.
Okay, go ahead and enter into it. It's going to load what's called a Lua script. Okay, so this is an add-on, a script that we can do specific things, additional things with. Okay, if you see here at the top, it recognizes we have a beta FPV 2.4 gigahertz nano. That is exactly what I have right here. Okay, so we want to check what firmware we have. So let's go down, and we're going to see I have firmware 3.54. All right. Now the reason I say this is because there's 2 ways. I'm just going to write it down. 3.54. There's 2 ways you can set the binding phrase. You can either just set the phrase, or you can update the firmware and push a binding phrase with it. So let's see if we need to update. We might as well try to do that and the binding phrase at the same time. Okay, so 3.54, let's check online what the latest firmware is. Beta FPV 2.4 gigahertz nano RX
You're gonna plug that into your computer and you're gonna plug
nano ELRS module. This is our module.
But you haven't, I don't think you've done a binding phrase yet.
No, I don't, I'm trying to catch up to him, but everybody is so far ahead.
Okay, let's see. Upgrade the firmware.
You have,
Yeah,
you have a dongle,
yeah.
and then a second. A USB or a micro USB.
That's a good one.
Wait, this is weird. This is 1.00. That's not right. We're definitely beyond that.
Is PPM the same as the ELRS on the
Mm,
Zorro?
no. Wait, let me see.
Would that be multi?
For the latest release, ELRS 3.60. Okay, so we might as well update because we have 3.60 now. You guys need a computer for this, by the way, in case in case it wasn't clear. Yeah. Okay, so we need to get this 3.6. Okay. So here's the Lua script right here on GitHub. Can you guys find this? The 3.6?
I don't know if this will. I don't know if this radio can do ELRS.
It does. It can do it. Okay. What we need to do is on your controller. This I don't know how this is gonna work with my recorder. This might so maybe I need someone else to try this. You need to go into Wi-Fi connectivity, and you're gonna enable Wi-Fi. You see that?
Which section are you in?
Another.
I'm in ELRS. ELRS.
Oh, I left it at
Let me
home.
tell you guys to that system. Sorry.
You have
Huh?
it at home.
Actually, I might be able to do the Wi-Fi on here on my iPad.
Oh wait, we're doing.
Let me see. Oh, but everyone's gonna turn theirs on, so.
Your radio is not connected to your computer, just your drone,
Um,
or both.
I'm doing the Wi-Fi option. So let me see how well that works. Oh shoot, I just saw it and it went away. Okay, let me try this one more time. So I'm entering the ELRS Wi-Fi. It's gonna
Another
pop
one of
up.
those, huh?
It's gonna pop up with a screen, just like when you're trying to enter a password to like a there it is. Okay, here. We have this. If you don't have it pop up, you can type in 10.0.0.1 to a web browser. Maybe I'll write that down.
We don't need to put a Miss Towers doing the Wi-Fi connection.
Oh, sorry.
So I'm using the Wi-Fi. There's multiple ways to do this. Right now, the binding phrase right here, I can call it something. I'll call it. Okay.
You have data port? Yeah, so you can put.
Okay, I'm gonna call my binding phrase instructor.
I'm way lost.
Okay, we have two things that we need to set the binding phrase. We have the controller, the transmitter, right? This is transmitting the signal. Then we have the receiver. They need to have the same binding phrase so we can talk. So right now, if I go to receiver, oh shoot, it's already working. Yours is already working. So let me see if I can like. All right, here's what I would do. I'm gonna change the binding phrase so then it will stop working.
Sure.
So I'll just walk through this anyways.
Well, it has a
Oh, I'm gonna have to get back on how to update that because right now, doing it through the iPad is a little bit tougher because you have to download like a file and everything. Okay, so I'm gonna start with the controller. Okay, so on the oh no, on the controller. Sec. Oh, I unplugged it. Right. Too many cables. Too many cables on the computer. I was like,
Hey, look at that guy.
okay, so on the controller, we're gonna go into. Let me just start. Let me start with the. Oh, what the heck? Can't even get out of this mode. I remember this is like one of the annoying things about. I'm just gonna turn the whole thing off. There's like a bug in that script where you can't get out once you get in. Alarms disabled. Okay. Okay, so from the home screen, we're gonna press System,
I mean, TBS.
and then that's gonna bring us straight to page 1. I'm gonna scroll until I find. We're gonna find Express LRS. In this case, it's the second item. Okay. This only works if you have the thing plugged in, by the way. So make sure your thing is plugged in with that. Okay, we're gonna enter. It's gonna run the script, and we're going to scroll down until we see Wi-Fi
Number 2.
connectivity. We're going to. Hmm?
ELRS number 2, and then what did you do?
And then
It's loading.
scroll down.
It's loading. all
Are you
the-
in the ELRS configurator?
The one step.
So you're gonna scroll down to Wi-Fi connectivity. And then I'm gonna enter into Wi-Fi connectivity. I'm gonna enable Wi-Fi, not RX, just normal Wi-Fi.
Oh, it was the same.
Oh,
It's loading.
shoot. Maybe don't do this all at the same time because otherwise I don't know who's
I'll turn mine off.
whose is whose. So yeah, let me just do this one. So maybe don't enter Wi-Fi. Just watch again.
Yeah, I didn't enter Wi-Fi yet.
Okay, I'm gonna enter Wi-Fi. Hello. Okay, enter Wi-Fi. Okay, now on my iPad, I'm gonna go and I'm gonna find Express LRX TX transmitter. Okay. I wonder if there's a way I can change the name. That way we don't have to do this waiting game.
That's what I was wondering.
I'll look into it once. It's gonna pop up with this screen that I was waiting for. You should be able to type in the 10 point. You see right here, 10.0.0.1. Okay, binding phrase. Robert, what do you want it to be called? What's your unique binding phrase?
How do you get to that page?
It popped up on its own.
Oh, okay.
Once you connect,
Once you click receiver,
this is your.
right? Once you click receiver.
I don't know.
I think you.
Dune?
Dune. D-U-N-E? Yeah.
Doom? Oh,
Dune. D-U-N-E.
okay. So if you look as I'm typing stuff, we have like a bunch of string of numbers, right? So this is kind of specific to whatever string you put on there. You see the modified?
Yeah.
Okay, so that's actually what it sends over. So let me just take a photo to make sure that it matches up with the next one we do. So Dune with a capital D, okay? Oops, let me take another clear photo. Okay, we are going to. I'm going to go to Wi-Fi and currently in access mode. I'm wondering here is maybe we can change the name. What do we want to change it to? Let me try something. Express LRS. What's your? This is number 10.
No, it's done through Wi-Fi.
TX 10. Okay. Confirm.
Yeah, he has his drone.
Yeah, we should do it.
Yeah, the drone's got a.
Let me see if it works.
connected to the computer.
Ah,
That makes sense. That's why you're gonna have
it apparently still didn't take it. Okay, well. All right, well that's okay, I guess. That's kind of annoying.
Did you have to navigate to the 10.0
No, I see it popped up on its own just now. Okay.
Oh, no.
I don't know. That might be something I have to look up later. Dune. Okay, we save it, reboot. Let's just double check here. If I go into here again.
Oh, there it goes. Once the drone is in, okay, nice. Drone receiver, and you can pops up in this Wi-Fi setting. You have to go to oscarlion.com and do something.
Uh-oh,
That's where he was checking.
Uh-oh.
There's a walkthrough.
What the
of how
heck?
to do this, because there's multiple methods on binding. This is the Wi-Fi method. But Oscar Ling has the
Oh my
the
goodness.
little walkthrough on it.
I'm gonna reboot this controller. Okay, I'm gonna go do the same thing. System, Express LRS, Wi-Fi.
System, you said system, huh? You said system.
Yeah,
Enable.
so on the
Okay, I'm running the Wi-Fi. I'm gonna see if I just need to go in and confirm that the name has indeed been changed. There it is, Express LRS TX. And Dune, the ID is supposed to end in 38, 25 or 205. So let's see if that's the case. 38, 205. Okay, good. It did keep that. I wish it actually had the phrase in there, but that's why I had to take a number because I don't remember it in number form. Okay, so now that it is changed. Again, there we go. Now that it's changed, I should not be able to control this drone anymore. Let's see. Yeah, I'm moving the sticks. It no longer works because whoever had the other binding phrase, it's different now. Okay. So now we got to set the other thing to the binding phrase. So what happens is the first time you plug it in to give it power, so I'm going to disconnect this drone. When you plug it in to give it power, it's going to wait 60 seconds, and then it's going to enter into Wi-Fi mode on its own. So we're going to look and wait here for Express LRX RX this time. Okay, so we have to wait until this thing goes into Wi-Fi mode, which is going to take about 60 seconds. Give it a sec. How's that 3D print looking? Is it sticking? It's no failure? You have to walk up and look at it. It's hard to see from. Just make sure it's sticking onto the plate. Oh, okay. That's good. That's good. All right. It should be entering Wi-Fi mode anytime now.
But I don't know. It's a little tricky because I don't know exactly. He's doing the classroom one, and I'm not sure how this one is going to do the Wi-Fi button.
Okay. Now it's rapidly flashing. It's entered into Wi-Fi mode. Let me just force it to find it. There it is. Express LRX RX this time. I'm going to click on that. We're going to get the same dialog box show up.
Oh, there it is.
Yeah.
That's for his.
Yeah.
Kind of have to wait. There it is. Okay. Whoa. Oh, this one looks different.
There's a Wi-Fi tab.
Yeah, but this looks different than the one I had previously. Okay. Well, yeah, we should put this in here. It should be Dune, right?
Yeah.
Yeah.
Save. Oh my goodness. What the heck is this?
The binding phrase above that Dune one said persistence. I don't know if that had to match.
No, persistent is like a It's an option. Oh, that was not good. Let's try that again. I don't know what happened there.
So Wi-Fi is not the norm. That's just one method.
Yeah, I mean I would say that's the, or you can plug it in manually, and you can like plug it in, and then you have to use the Express LRS configurator, which I had pulled up previously. Yeah, ELRS configurator right here, and they have a they have a web app version, I believe.
Express LRS configurator.
Yeah,
ExpressLRS.org.
the web UI. Here we go.
Yeah, and then navigate to the configurator.
Well, why is my thing not? Thing is still not popping up. Okay. There it is. Okay. Okay, I don't know why that other screen was weird. This is the screen. Oh wait, this is the screen we want to see. Okay, you can see it has a like whole binding number. So Dune 38,205, right? I'm going to say CRSF, good. Save. Okay, saved it. Now if I go into Betaflight, what the? Wait a sec now. Oh, this is talking. Oh man. Let me turn this off. Turn it back on again. Oh, it's still in the Wi-Fi mode. I think I'm still connected to the, yeah, I'm still connected to the Wi-Fi. Let me turn that off. Let me just disconnect this, reboot it, because it'll still, yeah, it'll still in the Wi-Fi. Okay.
We're doing the manual now?
Okay, so now we reconnected,
Still a Wi-Fi mode.
and now press any key. Okay, what the heck is going on? Oh, there it is. Okay, now it's working. Alrighty, see? Sorry, very convoluted. There is a faster cheat method, which I don't like to encourage, but it is the fastest way. The 3-cycle power cycle method. Basically what you do is in here, I'll just show you. The reason I don't like this is because it doesn't give you a binding phrase. So you would have to do this to every drone you have. And it assigns like a random binding phrase to it. So here you would go to system.
You're not sharing.
Oh, thank you. Here we go to system, and then Express LRS. And then down here, you would go to bind right here. And then it's going to be searching for like 60 seconds. And within that 60 seconds, what you do is you plug it in. Beep, beep, beep. I'll show you 2 cycles, but not the 3rd cycle. You go like this. 2. And then you go a 3rd time. And then it will rapidly flash in binding mode. And then this will sync. It's a lot faster. I would say that's a quick and dirty in the field method. But like for a more permanent solution, I would do the bind phrase. That way you can use the same bind phrase across all your devices on that radio. Yeah. So I know I really only showed number 3 and then 5 by talking through it, but not actually showing you. So if you guys want to try number 3 now, you kind of have to do it one at a time, unfortunately, unless I can figure out how to change the Wi-Fi name of Express LRS.
All I need is my finger.
No, we just need to see how the
Oh, maybe I can. Okay, I'm going to try this. Robert, you can have your drone back. Thank you. Okay, yeah, if you guys want to try it, you can. Let me unplug this. Yeah, so just announce if you're going to do it.
I'll give it a shot.
So you are doing... Okay, so I guess someone can do TX while someone's doing RX because they have different names. So he's doing TX right now. So if you guys want to set one of your bind phrases on your RX.
We don't know how this is the different drone,
It's the same thing. All you have to do is power it on, wait 60 seconds, and it will enter into Wi-Fi mode.
Before that,
Here you go.
do I keep it on multi or do I go to a different for
Oh, here, bring it over here, because I kind of need to set yours up a little bit.
behind?
Yours is like,
Can you bring my laptop?
no, just the controller. You guys are free to go, by the way. I think most of the class already took it upon themselves to do that anyway. Let me see what's
They're
up.
not cool guys. So happy. Take a bunch.